buenas tardes a todas, buenas tardes a todos. Es un placer para mí presentar esta sesión de Intele, este webinario de Intele, que es nuestro tercer webinario. Como ya sabéis, hemos tenido varios webinarios antes de la sesión de hoy. Hemos tenido ya el proyecto, hemos presentado el proyecto de Parlament en febrero y el proyecto también de Programming Historian en marzo. Y ahora en mayo tenemos pues otro webinario de cómo analizar textos, cómo hacer análisis de texto en castellano, en español, con Quinn Dombrowski. Y en los próximos webinarios tendremos también, pues por ejemplo, os presento pues facilitando el acceso computacional a colecciones digitales, que será en junio, o un proyecto de Distance Reading también que está bastante atado en junio. Y ya, antes de, pues ya hecho esta pequeña introducción, voy a presentaros a la conferenciante de hoy, y creo que es por todos conocido, Quinn Dombrowski, es especialista, por lo que he visto yo, en tecnología académica, está en el Departamento de Literatura, Cultura y Lenguajes de la Universidad de Stanford. Y, como todos conocemos, ella estuvo trabajando con el directorio de herramientas DIRT, que es, en su tiempo fue bastante, pues para mí, como un faro para conocer qué proyectos de humanidades digitales hay, qué herramientas, qué metodologías se utilizan. También estuvo en el proyecto Bambú, que fue un proyecto de ciberreestructura de humanidades digitales, y como en su página web, Quinn menciona que no fructificó, pero fue creo que un proyecto bastante interesante. Y luego también, pues para mencionar otros dos proyectos suyos que me parecen muy interesantes, es el Data Sisters Club, que es un grupo de investigación y de pedagogía feminista que trabaja con proyectos de humanidades digitales. Y, por último, también una cosa muy interesante, que es que, aunque está ya en Estados Unidos, pues trabaja y participa y enseña proyectos que no son ingleses, no English projects. Y, bueno, pues yo creo que también la sesión de hoy se titula Test Analysis for Spanish, que va a ser en inglés, la charla va a ser en inglés, pero yo creo que va a ser muy interesante pues ver cómo qué analizan, qué herramientas utilizan y cómo analizan los textos en castellano. Y para todo esto, pues os dejo con Quinn. Tenemos el código también que haya preparado para que podamos seguir todo, y os lo voy a compartir ahora por el chat. Y le doy a Quinn la palabra. Quinn, it's a pleasure to have you here with us, and I think you have 1 hour and a half to present your work and time for questions that we are going to do at the end of the session. So over to you, Quinn.
Thank you so much, and I am honestly very truly sorry that I can't give this presentation in Spanish. It's been about 20 years since I had the opportunity to speak Spanish all that often in high school, and certainly it's not going to happen today at 5 a.m. But you know, tal vez la próxima vez, espero. Okay. So what I'm hoping to do today is give you a bit of an introduction to text analysis in a very practical way, and talk about a little bit why would you want to do this anyways, and then we can look concretely at some of the things that you can do to make the text analysis tools that are common in English work better for Spanish. So to the question of why would you want to do this stuff anyways, you know, there are many different kinds of research questions that are much easier to answer if you give them to a computer than if you're left with your own eyes doing it. Basically, anything involving counting tends to be a lot easier and possibly more accurate if you give it to a computer to do. It's very time-consuming and tedious to do, you know, to go through counting where different characters occur, looking at what actions characters are doing, looking at how characters are described, trying to figure out other distributions of words. And this is not something that the computer does by itself. It has to be led by your own ideas and intuition about what you think is going on in the text. Maybe you think that a text sort of starts off, using a lot of nature words and, talking about, plants and trees, and then later moves into domestic spaces with buildings and houses and homes. And that can be an impression that you get reading a book with your own eyes. But using a computer lets us quantify that to be able to say how much more it's talking about trees and water and birds in the first half than in the second half. And it also lets us test our theories in a way that would be hard if we were just reading it. It lets us actually check that something is actually more common and isn't just, maybe there was just a very memorable scene of birds and trees in the first half, but it's not actually as big of an element of that first half of the book as we thought it was. So that's there are various other kinds of questions that you can ask, and the questions you can ask depend on the kinds of tools that you have, and the kinds of tools that you have also depend on the language that you're working in. So this should come as no surprise that most of the world of natural language processing, mostly people work on English. There's a lot of work even to this day to make tools for English perform just a tiny bit better than they have so far, and just improving it, ever so slightly, when it could be focusing on, making the baseline of what's available for more languages richer and more robust. So, for Spanish and for languages, for Romance languages in general, there are a particular set of issues that you have to deal with when working with those languages compared to English. English doesn't have a lot of inflection. Words don't change depending on the context. Adjectives don't really change depending on what they're modifying. Verbs don't change a whole lot. And as a result, the kinds of computational methods that come out of an English-oriented sphere tend to be based, many of the basic ones, on word counts, which seems like a great idea, but only works out very well if what you're looking at is a text in a language that doesn't change a lot. Computers do exactly what you tell them and nothing more, and sometimes you forget how limited your instructions to a computer are. So when you tell it to count the words, what it does is it counts all the sequences of letters between two spaces. And this can be a problem on multiple levels. If you're talking about trying to do this with a Chinese text, Chinese doesn't put spaces in between words. So you have to change the Chinese text into something that looks weird for a human reader in order to make it computer readable by putting spaces in between the words. And for Spanish and for other languages that use a lot of inflection, where the words change depending on how they're being used, you have spaces, that's fine, but it's going to count every single word separately. So, in English, red is red, the color red. But in Spanish, you have rojo, roja, rojas, rojos. And every single one of those for the computer counts as a different word. So if you're trying to count all the occurrences of that color in your text, you either have to search for 4 different things, or you have to do something to change the text to make a text that in morphologically kind of looks more like English. So what we tend to do there is something called lemmatizing. Spanish is fortunate compared to many other languages where people have built tools to lemmatize a text, which means to take the text that you as a human can read that is grammatically correct, where the adjectives and nouns and verbs all agree with each other grammatically, into something that the computer is happier to read. It changes all the words into their dictionary form. And so reading it as a human, like it reads terribly. You have to have kind of a derivative text because it really can, make it hard for a human to understand. But it makes it much easier for a computer to understand. So what I'll start with as a bit of a practical thing, you can either do this with me, you can do this on another text if you like. The link here is the GitHub repo. It's just sort of a web page with all the materials for today's workshop. But what I'm going to do, and feel free to just watch, or you could try this out later, is I'm going to use something called Voyant tools, which is an easy to use, relatively easy to use interface that many people use to get started with text analysis because it provides multiple different kinds of things in a single place. So let me open up Voyant tools and I will share my screen here. Here we go. All right, so this is Voyant. You can upload one or more text files, or you can paste text in this box, or you can put in the URL to a particular text. And in this case, I am going to pick out one of the text files that I also have on the GitHub page in this intro to NLP ES files. Or I actually have a group of them here. This is Fortunata y Jacinta, which Jennifer Isasi assures me that all of you have probably read it at some point. It always helps, by the way, to start off with a text that you've already read, partly because sometimes strange things can happen with text analysis, like things can break, counts can be off, files can be, messed up a little bit, and so it helps to know what things kind of should look like before you try out a new tool. So never try this, at least the first time, on a text you haven't read. All right, so I'm uploading the corpus. I broke this novel into 4 different files, basically because it was too large for my code to handle. But we'll get to the coding part a little bit later. So unfortunately, it has done some funny sorting things here. I'll talk about that in a second. I can give you an overview of these different panels. Here is a word cloud, which you'll see is terrible. Down here, we have a summary of the documents, which of these are the longest and the shortest, different vocabulary density, most frequent words, distinctive words about different parts of the book. And down here, this is actually, potentially somewhat significant. Here we have the reading panel, which is convenient because we can go back and check, where different things occur. We can look for character names, for instance, and we can see a little chart for how it occurs across the different parts of the book. Over here we have a graph showing the frequency of things over the different parts of the book. And this is where, unfortunately, the sorting order of this has ended up being a little bit funky, where the part of the the third part of the book is first for reasons I'm not sure why it decided to do that. But really, the biggest problem here is another challenge that we often encounter when working with non-English digital humanities, which is to say the stop word list for Voyant is terrible for Spanish. And a stop word list, when you're doing some kinds of text analysis, is the list of words that basically get filtered out because they're super common and don't add a lot to the meaning of the thing. So, it's always good to check your stop word list regardless of what language you're working in, there are English stop word lists that are not very good. For instance,
sorry.
that may. Oh,
Sorry,
yeah.
Quinn. We cannot see your screen. It's
Oh
black.
no,
It's all
I'm
black.
sorry. Let me figure out why it's showing in my preview button, in my preview box. Oh, so some people can see it. Okay.
I see only black. I don't know why.
Oh no, all right, let me stop and I'll reshare then.
Okay, thank you.
No, yeah, please, all right, I'll stop this and let me share it again. Okay, is this working now for people?
Yeah, thank you.
Okay, great, perfect. Okay, great. So stop word list. Yeah, as you can see here, this is not a good stop word list. So many common words that don't add a lot of value to the content are showing up here. So what we need to do, and honestly, this is a good idea regardless of what language you're working on, is to check the stop word lists. So here we'll go to this toggle where it says define options for this tool, and we will hit edit list. And this may be kind of tiny for you all. I'm sorry if this is hard to see. There are some things that are on here. You know, trabajar is on here. I don't know, that might actually be a word that you want to see in the context of your book. So you might decide to just delete those, because those are actually valuable words. There's also tiempo, which again might be a word that you actually want to be able to see. But there are all sorts of words that you almost certainly don't want to be able to see, which is everything in our word cloud here. So going back to the GitHub page, I have a list here of the words that I filtered out as I was playing with this earlier, and led to a much more contentful visualization. So I just pasted those in. And we hit confirm. And now all of a sudden we have things that are much more sensible and much more contentful. We see the names of characters. You know, we see you know, some nouns. There's a few verbs in here, and the word cloud by itself is at least anymore not often what people use as kind of the end visualization. This, like, you know, putting out a word cloud is not really what people do for a final analysis, except maybe in you know, undergraduate papers. But it's an interesting you know, way to kind of explore text and to surface things that you might want to look at more closely. So here, with again apologies that things are out of order, we can look for words. With Spanish, before you lemmatize a text, it can be helpful to use put an asterisk at the end, the star, because that will search for things that have other characters at the end. So mujer with an asterisk will get you mujeres, but also other things, mujercita, mujerona, and so forth. So if you want all of those things, you can use the star here, and here you can look at this. Oh, sorry. So you can compare the frequency of multiple terms here. I'm seeing that here casa and calle are appearing in the word cloud, which means they occur a lot. So we can look at those too, to see what's happening there. And one thing that's important to notice here is that the y-axis on this graph is a relative frequency. It's not looking at absolute counts. It's looking at how frequent the word is. So how the count of the word divided by the total number of words. And in general, we try to avoid using word counts. We try to use word frequencies wherever possible, because often we're comparing texts of very different lengths. And so knowing that there are 5 occurrences of kaije in the in your text, is that a lot? Is that a little? I mean, it depends on whether your text is, 50 words long, 500 words long, or 5,000 words long. So in general, frequencies are what we try to use. Improving our stop word list has also improved our most frequent words, and this is getting us into kind of a zone of common findings with novels, which is to say, the word said or dijo is very, very common because it's used to mark narration. We see that of the characters in this novel, Fortunata is the most prominent, and we can look at this across all of the pieces here too. That there's a dip in that final section. I believe that's after she dies. Maybe there's a dip there, and then she sort of comes back, and we can compare the other main female character. And even just here, we can see, although the colors are not great, kind of these opposite polarities where one goes up, the other goes down, and vice versa. Which might be something that you could get out of reading it with your eyeballs. But you can see it much more kind of vividly and clearly if we also put here and then so here we can see yes, again, some of the major characters and the ups and downs and the ways that they reoccur. So this kind of graph where we see the frequencies over time is something that people might include in a research paper about it as an illustration of these trends in terms and the way that characters are appearing or reoccurring close to each other. There are some other interesting things that you can do in Voyant here. You can look at some stats for these different pieces of the book. Again, this is a little bit more interesting if you actually have it broken up, by works. If you have multiple works by the same author, you can see whether the way that they're writing is changing over time in a way that's more easy than doing it with your own eyes. You can see phrases. It turns out it looks like there are no phrases of many words that reoccur in the book. Some books have tropes or sayings or phrases or things that like characters repeat that are very characteristic of that character, and you would see those here under phrases. Over here under context, this can be kind of interesting. You can put in a term and see where this is getting in the way here. You can put in a term if I can. All right, hide this message. So if we say Fortunata here, you can see kind of the context where it occurs. So these are the words immediately to the left of her name. These are the words immediately to the right of her name, and you can search or sort of sort alphabetically one way or another. So these are all Fortunata, and it's an interesting thing to explore. If we look at correlations here, we can also put in terms, and the correlations are basically terms that tend to go up and down together. So if we can get this to load successfully, we would expect to see that Fortunata y Jacinta are not correlated really like at all. They're going opposite directions, and they don't go up and down together. In fact, when one goes up, the other seems to go down. So if we look here, so we can see that hombre and Fortunata tend to go together here, I believe. Oh no, these are I had them sorted the wrong way. The higher the correlation value, the more likely they are to go together. So we expect hombre and Fortunata to be going in different directions, and indeed, we see kind of the same pattern of ups and downs as we would expect. They're not going together much at all. Dijo, you know, correlates with Fortunata, but again, that basically just means that there's a lot of dialogue involving her. All right, so I could go on at great length about other ways to explore text with Voyant. I use this a lot as an introduction tool, you know, especially for students who are not necessarily comfortable going right into analysis code, and even for the students who you know, want to jump into Python immediately and don't want to play with this sort of fun, colorful interface. I still encourage them to try it because the amount of work it takes to you know, write the code for kind of any one of these different kinds of visualizations, it takes a lot of time and effort. Whereas if you just plug your text in here, you can explore it, you know, look at these different charts, look at the correlations and contexts, and use that to get ideas for what might actually be an interesting question to pursue. And then if you want to pursue that with code, you can carry on and do so. Now, this is okay. The fact that we have this wildcard asterisk sign for Spanish can make a difference. But part of the challenge is that the asterisk is a very general thing. It will take any characters, any letters that are after the word that you put in, whether or not those are letters that represent you know, the plural or you know, a different gender. So if we here, this is working out okay, except, you know, Bonija is going to be caught in this if we include the asterisk here. If we do bonit and then put a an asterisk, we should be getting like just the right forms of this word. But sometimes you want to not have to rely on the asterisk, especially when you're doing, you know, counts. And anything here about like the most frequent words is going to be influenced by the fact that Spanish has inflection, and you know, common words are going to occur in different forms, which is why we mostly see character names here under the distinctive words, because these are less likely to change. You know, monjas, there's a monastery involved. Superiora. So I mean, again, this is an adjective being applied to one nun in particular. But maybe what we want to do is try this again with a lemmatized version of the text. So I'm going to go back to Voyant. We're going to start over. And instead, I'm going to upload the lemmatized version of all of these. Here we go. So we have lemmatized. Okay, we're going to open this. And we still have to fix upward list again. This is every time we need to be able to paste those stop words in. Paste those. Confirm. And now, haha, suddenly we have a lot more verbs occurring. So in our previous version, those verbs weren't occurring because they existed in many different forms depending on you know, who was saying them or what character or characters they were referring to. But once we lemmatize them, the computer can count them correctly as all the same thing. So our character names are definitely pushed down in the size of this visualization. You know, you can almost barely see some of the words that were very large in our last version, and they're being, I mean, here we have potentially another problem where you know, haber is used in compound verbs, so we don't actually want that necessarily to be our main word. That's not actually necessarily very informative. Decir makes sense, querer makes sense, poner, dar, parecer. But we're getting more about what happened and less about just like what's the distribution of characters here. So now we can do things like searching for individual verbs over time. This should be quite high. For querer. And so we can see kind of like how some of these verbs relate to each other. So I'm going to, because screen sharing seems to be a little bit challenging, I'm going to just open one of these files in the browser so that you can see it. And this should kind of hurt to read. It is not meant for human consumption. It is meant for computer consumption. And one of the annoying things that comes out of this is that you know, for English you can pretty much use the same text for the computer that you use for your own reading. And so in Voyant, actually this is another place we can look at it. In Voyant you can, you know, comfortably read from the reader panel, and that's fine. But looking at this text, it's just it hurts a little bit to read this thing. But unfortunately, this is what we need to do to get the computer to do what we want here. Okay, so let's actually practice doing this lemmatization. I have a variety of other more complicated things that we can do using the NLP toolkit Spacey. But there are once you get practice lemmatizing your text, suddenly a whole bunch of things are available to you that don't require a lot of additional coding. So for things like topic modeling, you may want to lemmatize for that. You know, anything involving word counts, so all of the word frequency things that we can do with Voyant become available. So I mean, lemmatizing, if there's one skill to learn to actually do if you're working with Spanish text, I would say that would be lemmatizing. Once you can lemmatize, there's a lot of things that sort of become possible. So unfortunately, there's currently no easy web interface for doing lemmatizing. It's also a little bit, it can be a little bit computationally intensive. So I would be surprised if anyone were in a hurry to set something up soon. Just their compute costs would might be a significant thing. I've talked to the Voyant people about you know, maybe including lemmatizing as an option here, but yeah. So this is something that you need to sort of do on your own using code. So what I've done in this GitHub repo that is linked in the chat here is I've created this a set of Jupyter notebooks that basically provide you with the code and explanation for what you're doing. So this is probably a good moment to talk about Jupyter notebooks and what they are and how they work. Jupyter notebooks are a way to, as I mentioned, combine both code and text. It sort of lets you, you know, read narrative prose and then run a code cell, and the computer does something, and you can see the output of it often. So increasingly, and maybe not as fast as I would like, you know, there's some interest in using Jupyter notebooks as a publication method. So, I mean, you may have read articles that use computational text analysis methods. And it's always frustrating to be reading about people's research, and then there's a footnote that says my code is available on GitHub, and that's it. Like, it's left to you to go to GitHub, find the code, figure out which code matches which part of the article, maybe try to run it yourself, or maybe they can't share their text because of copyright reasons, and the whole thing is just a mess. Whereas with Jupyter Notebooks, you can actually, be reading, CSL, run it, and then, see the output for yourself and keep going. So for this project that I'm doing, the Data Sitters Club, we've started using that to publish our pieces, where we have these narrative sections here. There's a sidebar here with kind of the different sections of our document. And if I go down to one of these, you can see the code that I use to run it here, and then all of the outputs occur below. So here I'm trying to compare a bunch of different texts to one another, and if you keep scrolling, you can see the values for each of those documents. And if you go a little bit further, you can see some of the code for the visualizations I did, and the outputs from those. All of this while you're reading this piece. And you can also, for that matter, download the source file that I used to run this. So you're not going to have to write Python code yourself to do the lemmatizing. I wrote one here for you. If you hit the Open Spanish Lemmatizer, what this will do is it will open the Jupyter Notebook in Google Colab. And Google Colab is, it's like everything from Google. It is kind of a miraculous tool that is free, and lots of people use it because it makes running Jupyter Notebooks very easy. I don't entirely trust it because I suspect that at some point they'll make it paid like everything else, or maybe it will go away. And so it's one of those enjoy it while it lasts kind of tools. But we will get to enjoy it today. So it uses Google servers to do the compute for Jupyter Notebooks. Jupyter Notebooks are great, but the setup for them, especially on Windows, can be a lot. Of maybe 5 students running Windows when I taught in the fall, I maybe got one of them to be able to run Jupyter Notebooks locally, because there's all sorts of Windows-specific dependencies and things you have to add on, and it takes a lot of hard drive space. On Mac and Linux, it's much easier. It's fairly painless. I run it on my own computer all the time. But especially for a workshop, we could spend 2 hours just installing Jupyter Notebooks on machines, and that would be it, potentially. So we're gonna try to run it in Collab. And so Collab also has a way to connect to your own Google Drive. So if you have files, crucially, if you have plain text files in your Google Drive that you want to work with, you can connect to Google Drive and use the Lemmatizer on them. Step 0 in all of this, by the way, which I should have started with, is the fact that you need plain text files to be able to do computational text analysis, like, period. You can't do it with Word docs. You can't do it with PDFs. If you have PDFs, you can convert them to plain text files, either by doing what's called OCR, optical character recognition, which basically takes PDFs are often just a picture of text, and what it does is it reads that and converts it into text that you can highlight, or for that matter, you could export as a text file. So you gotta start with plain text files. Also, you may run into something called Unicode or UTF-8. That is good. Use Unicode or UTF-8 if it's ever an option for you. Different interfaces tell you, you can choose whether or not to use it. If you're not on Windows, odds are everything's in Unicode anyways. If you're in Windows, it may give you other encodings, but choose choose UTF-8, it's now the universal standard in text encoding, so that you can read multiple languages in the same text file without things getting messed up. All right, so, wrong button there. What we're going to do is, if you go to that GitHub repo and hit the Launch Spanish Lemmatizer or Open Spanish Lemmatizer, it should get you to this screen. And what you might also want to do is go to your own Google Drive, and if you go to the GitHub repo here, you should see this intro to NLP ES files. So if you take these files, you can either maybe the easiest way is to click on them, and then if we go to raw here, you can just save this as a file on your computer. So we'll save 3B. We can go back, save 3A, raw here, save this. So once you save all of these text files to your own computer, is there a, oh yeah, I had major spelling problems with Jacinta. Apologies for, I don't know why this misspelling got stuck in my head. I had the curious occurrence even of there being no verbs at all for Jacinta in the corpus, because I made that same mistake in the code itself. So apologies for whatever strange bug in my head led to that typo, which happened multiple times. Oh, that's right. The file name. Yes. Okay, thank you. You've solved one of the mysteries this morning. Thank you. Yes, that must have been exactly what happened there. Yes. So again, perfect illustration of like a stupid typo can lead to all sorts of things, further down in your research. And it's so easy to do, and it happens all the time. So when it happens to you, don't feel bad, because it happens to everyone, especially before coffee. Name error, so often, or like name is not defined because you forgot to hit go. Anyways, yep, that's exactly what happened there. Okay, so once you get your files, you can feel free to correct the spelling if you would like. Once you get your files, I would suggest going to your drive here and creating a folder. What I called mine is the same as this GitHub repo, the Intro to NLP ES files here. You can call it something else, but if you call it exactly this, then you won't have to change the code. So that might be convenient. I'm going to delete these extra files from when I ran this code last night. So my folder looks like yours. All right, so hopefully you have or will soon have on your own Google Drive this Intro to NLP ES files with these 4 files. Yep, that's my typo. I'll go fix that now. With these 4 files named correctly or not in it. Okay, so once you have that, we can go back to this Spanish Lemmatizer and start working through the sections here. So you can read the text here. I tried to explain everything as we were going. And then once you get to a code cell, which are these gray ones here, you can hover over it and then press this play button. This first one is the one that connects the notebook to your own Google Drive. So we'll hit Play? Yes, I know. I know it wasn't authored by Google. It was authored by me. I'm not trying to steal your data. I'm just trying to misspell your characters. Okay, so follow instructions here. Go to this URL in a browser, which basically just means click on it. And I'm going to authenticate with this account. And we'll hit allow. And then you copy this whole thing here. And then we'll close this window that popped open. And we've got to paste that thing in here and press enter. It thinks about it for a second. There we go. So when it stops spinning, it means that the code cell is done running. And the happy message that we want to get here is mounted at content G drive. So we got it. Then there is some setup that we need to do. There are some Python libraries that we need to download and install and run. This is Spacey, which is an NLP, natural language processing package for Python that that supports multiple different languages. It's commonly used, especially commercially. It's fast. It's pretty good. It's gotten better for Spanish. I was pretty horrified at first at what it was doing with some of Spanish prepositions. All right, so we've installed Spacey. Now here we need to download the Spanish model. So Spacey is kind of a framework for doing this in general, and then you have to download a language-specific model. So we're downloading the large, it's about 500 megabytes, so it's the most accurate Spanish model, which is largely based on a corpus of news documents. So this, yeah, an earlier version of Spacey with the smaller model had the bad habit of taking all the prepositions para and turning it into parar, which is not at all what it should be most of the time. But it's gotten better usually. So here it goes. It downloads. If you want to work with other languages with this Lemmatizer, you can go to the Spacey models page. There's a link right here, and choose a different model, and then all you have to do is replace ES Core News Large with that model name. And do it for French. You can do it for German. They also have Lithuanian, Macedonian, Japanese, Chinese, many languages at this point. Russian now. Okay. Here, the next one, we've downloaded a bunch of things. Now we need to sort of import them. We need to sort of make them available for the code to use. So we're going to run this one. That was pretty fast. Okay, so for your convenience and future use, I set this up so that there are two different ways you can do it. If you have a single text that you want to lemmatize without having to deal with like a folder and things, you just have a plain text file and you want it done, you can use this section here, where you put in the path to your file, and then it will lemmatize it and save the lemmatized version to the same place that in your drive that the original file was. In our case, though, we have multiple files, and it'd be kind of annoying to have to do that for every single file. So what we're going to do is we're going to skip down to lemmatizing an entire folder of text files. Here we have the path to a folder in my drive called Intro to NLP ES Files, which is the same as we see here. It's in my drive. You can have multiple nested files. You just kind of add a slash and keep adding things to the path here. But this should work for my folder, and if you named your folder something else, just put the name of your folder here instead. So this says, all right, define where your text folder is and then move into that directory. So we'll do that. That was fast. And now we're going to hit this one. This one's going to take a couple minutes to run. And what this one does is it says for every file in this directory, if it ends with .txt and doesn't end with lemmatized.txt, because that's lemmatized.txt is what we're adding on to the file names of the files that we've lemmatized. Then it's going to create this derivative lemmatized file, and then it's going to read it. It's going to do the natural language processing analysis on the text. And then for every token is basically word in our document, we are going to write out the lemma. So what NLP does is it takes your text and kind of creates this this compute object, on kind of accessible to Python, where all the words have additional metadata about them. It basically annotates your text for you, saying what part of speech a word is or how it relates to other words in the same sentence or in the same text. And it also, for languages like Spanish, it lemmatizes it in the sense of it adds an annotation that is the lemma or the dictionary form. And so once we've done this processing, we can have it write out the metadata about the lemma. And so if I'm impatient and go back to my folder here, we can see that it looks like it's probably done with the first text. If I click on this, here we are. This is our lemmatized version of text 1. One limitation of Spatie is it is very memory intensive to do this analysis and annotation. And so you definitely shouldn't have a text file that is greater than 1 megabyte. I would probably keep it under 800 kilobytes just to be safe. Nothing terrible will happen if it's over a megabyte, like the code will just crash and it will tell you like out of memory, won't do it. So with very long text like this one, you may need to break it up into multiple different pieces. You can always combine them back together afterwards. Although as it happens, it is convenient for Voyant to be able to have multiple different documents, because then you can kind of compare across them rather than just having the info for one. And this is another thing in general with computational text analysis, like it helps to be able to compare something. Even once you get numbers for some phenomenon in the text, if you see for one text that hombre occurs more often than mujer, you might it's hard to know necessarily is that an interesting thing about the one text I looked at, or does that happen in all texts? So it really helps if you can have multiple texts to compare to start getting a sense of what is a book phenomenon, and what is hello, that's Spanish for you, phenomenon. So that's sort of worth keeping in mind as you think about what kinds of questions to ask with these tools. All right. Oh, we're getting there. We have one more file to go, it looks like. One of the annoying things is it actually does take about as long to lemmatize a text as it is to do some of the more complex things that we can do. Oh, here we go. I had it print a happy message at the end that your folder now has lemmatized files, and indeed it does. Here we have 1, 2, 3, 4. So what we can do is we can download them. Select all of these and download. All right, so I'm going to unzip my folder with my 4 files, and we'll go back. And now that I have fixed my typo with por Jacinta, who I want to spell with a D, we will get them in the right order with any luck. All right, so no, sorry, upload. We will go to my downloads. This is what I just downloaded. Here we have our lemmatized files, now sorting in order due to that typo being fixed. Very nice. And yeah, we got to go back and fix our stop words. But we can see the different sizes of these documents here. They are sorting in order. We will fix our stop words, and we should see, that was my Google Access code rather than my stop word list. I'll go back here for my stop word list. All right. Confirm. So here we are. All of these sorting in order. We can now look at these characters distributions. There we go. Yeah, and actually, even after, I mean, this could be, if you actually wanted to look at this novel seriously and not just as an easy demo, what you would probably want to do is break it up into the actual constituent chunks of the text. So I tried to roughly do it in the 3, like, one is actually parte primero, but you might want to break it down even smaller into like individual subsections and individual chapters so that you could see kind of more easily like where people are going up and down. Because I would guess that like Fortunata is like, if I recall correctly, she dies at some point, and so she would probably mostly disappear from the text, unless of course people are talking about her, which sort of brings me to potentially the next part. Where I put together another notebook with some fancier NLP things to look at, one, potentially extracting all of the nouns from a text, which might actually make them easier to compare to each other in terms of content. And I have another one that pulls out, hopefully, all of the verbs used with a particular character. But I'm also aware of the time, and so probably walking through everyone doing these notebooks together would probably take us until at least another half hour, and there might be some Q&A. So maybe what we should do is why don't I take any questions on this so far, and then I can show you how to use the other notebook, and then you can be set free to play with it, and I'll stick around until the 2-hour mark if anyone has questions and wants to stay that long. Does that sound good? All right, any questions? Or you can type them in the chat. If you want to type questions in the chat in Spanish, I can also follow it. But oh yes, I don't know how to call on people.
Yeah.
Feel free to unmute and ask.
Yeah, Javier.
Hi.
No, we cannot hear anything.
Oh, there you go. I think it's. Oh, okay. so can you download quantitative data from Voyant? That's a great question and something I should have shown you where that is. Yeah, so there are lots of different options here. This is the export icon, and you can see that on any panel here. What it allows you to download depends on the panel, but you can export the tools and the data. You can export the visualization. So I don't think it, well, let's see. I don't think it usually lets you export like a CSV, but you can download no, or you can export the current available data as JSON or as tab separated values as text or tab separated values. These are the same things. Oh, this is the current data versus all possible data. So yeah, you can download this. We can take a look, for instance, at what. Yeah, so this is what you get if you try to do the export. I wonder what can we do that here? Yeah, I think here it will just sort of give you this list of things rather than like data in a format that you can work with easily. Okay, yeah, I haven't tried comparing it to English. That's a good question, and actually part of what we're doing with this Data Setters Club project, where we have you know, probably now like 8 or 10 different translations of these girls' books into you know, multiple languages, including Spanish and Catalan. And looking at kind of what things, particularly what cultural references, like American cultural references, are not translated, and which would sort of impact how it's being used. Okay, so the language models. This is not the best place to look for the language models. That is kind of like the dream model list, rather than models that you can actually use today. What you want to go to, I have linked here someplace. This is the page you want, spaCy.io/models. These are the ones, these are the ones with more or less comparable functionality across the languages. These are the ones that are usable. Maybe varying quality, but like they're all pretty good. Anything on the GitHub page is really more of a dream. Some of them like just include the alphabet. Unless you're actively involved in working on one of those, and honestly, I think given the amount of work that's been done, you know, by this team and others on Basque, that could be an interesting one to try to integrate into the spaCy framework. But like, if you want something that is usable, this is the spaCy.io/models is what you want to look at. Accuracy to NLTK. So as like NLTK, my understanding of NLTK is that it is used anymore mostly as a framework for teaching computer scientists like how NLP works. And you know, there are lots of convenient things where you can like download different corpora and do different things with them. You can try to train NLP models, you know, in a way that like is useful for teaching. spaCy is oriented towards getting things done. It's used a lot in industry. It's used when like you just want to like get stuff. There's a third option that is getting some uptake in Python as well, called Stanza, from the Stanford NLP group. Stanford NLP has had Stanford Core NLP is a sort of big slow Java package that has been used for quite some time for doing NLP stuff in a couple different languages. But Stanza has now supports many more languages and is Python based, which is appealing for lots of people. Yeah, I mean, with Spacey also there are some tools. These unfortunately are not free, that allow you to easily train a model. For instance, you can train the Spacey named entity recognition capabilities to identify certain kinds of things, which kind of gets to the question about compound nouns. You can the named entity recognition functionality is good at sort of identifying certain kinds of compound nouns. So things like names of organizations, names of people, names of places, and different models support different kinds of things. So the Chinese model, for instance, and to my great surprise when I discovered this, it includes a named entity recognition for cause of death. Which I think maybe was originally used in like medical context, possibly. So things like heart attack or car crash or explosion. I don't know whose job it was to come up with like the training data for this. But the interesting thing about NER, named entity recognition, is that it's not just based on lists of things. It will it learns context, and so it can kind of like, you know, even if it's never seen a word before, if it's used in a way that it thinks is similar to the way a place name is used, it will probably tag it place name. And so when I've trained a model for the Data Setters Club looking at foods. I was trying to tag all the names, like name brand foods, all kinds of American candy and things like that. To see how they, to find the places where food occurs so I can compare to the translations more easily. And it's pretty good. I mean, pretty good for named entity recognition is like maybe like 60–70% accuracy. Named entity recognition, even for English, even for common things, is not really great still. But there were some funny mistakes that it made, where it thought that a hamster was food, small pet. Yes, okay. Jupyter Notebooks for Code Teaching. I have exactly the document for you. So Programming Historian has a lesson that I and some colleagues wrote, and this is, oh, it's not available in Spanish yet. It's available in French, but it's not available in Spanish yet. But it is available in English or French, depending on how you feel about those. This walks through an example of using Jupyter Notebooks for research, but also in the classroom, working with students, using it for publishing. It sort of walks through the whole thing. So yeah, this is the English version, and I need to talk some people into translating it into Spanish. I think. Are there any other questions? All right. If there's no other questions, let's try out the other notebook that I have linked from the GitHub repo here. The Open Spanish NLP in Google Colab. And we should be able to at least get through the beginning of it. You're welcome to just try it yourself, follow along, watch while I do it, whatever is most comfortable for you. I thought I had cleared this. Okay. One thing you can do if you get back to a notebook that you've written before and run before, or in this case, I think I forgot to clear my outputs when I saved it to GitHub. One thing you can do to basically like wipe it clean is if we go to where is this? Edit, and then clear all outputs. So this should clear things out a bit so we can run it all over again. You can run it even without clearing those outputs, but it may be a little bit easier to keep track of what you've done and what you haven't done if you do that the first time, just to sort of wipe it clean. All right, this is a new notebook, so we have to do our Google authentication again. Choose my account. Right, paste this. And then while it's thinking about that, I'm going to start Spacey installing because I know that takes a minute. We're still waiting for the other cell to finish. There we go. Now it's running. All right, now we're going to install our model again. Do. All right, almost done. Yeah. Okay. Nope. Still going. There we go. Okay. Now we'll run our import module code. And this is one where if you're trying to get a sense of what Spacey is actually doing to annotate your text, you don't necessarily need to load a file. What you can do is you can basically just put some sentences right here and then see what happens. So here we're defining example to be this sentence from Nata Hacienda. And then we're going to do our NLP, our analysis of it. And then for each token, so for each word, we're going to print the token text, we'll print the lemma, the part of speech, the sort of tag, which is like a more detailed part of speech information, the dependencies, the shape, whether it's alpha. I'm honestly not entirely sure what those ones do. And whether or not it counts as a stop word according to Spacey's own list of stop words. So here we go. For one sentence, it's really fast. And you can sort of get a sense of what these different pieces are. So this is the, you can sort of scroll up and down. This is the verb. This is the lemma of the verb. So if we were lemmatizing it, this is the word that would get written out here. This is a verb, also a verb, and it is the root. So it is kind of the core. The language of this can be a little bit confusing sometimes. This is root in the sense of syntax, not like the morphological root. This is like the verb that is kind of like the key verb holding down the sentence. And here we see, all right, here's our name, Massimiliano, PROPN, and this says this is a proper noun. So when we go down a little bit further and we get to the code cells where we're writing out all the nouns, this would not count as a word that we would write out because it's a proper noun rather than a noun, which is good and which is part of the reason why we might want to just extract the nouns from a bunch of texts, especially if we're working at the scale of thousands or tens of thousands of texts. If we use all the words, there's a lot of words that don't relate to the book's content, and also there's a lot of character names potentially. And we don't, if there are two novels, unrelated, perhaps from different centuries even, but they both have a main character named Maximiliano, that name will occur a lot in both of them. And so, for purposes of computational comparison, the computer will think that those two books are more similar than they actually are, just due to having a character that has the same name, which is one of the reasons why we might want to strip those out before we start comparing texts, especially at large scale where we may not have read the books. Okay, so here's a determiner. Here we have a noun, we have another determiner, a number, a punctuation, a conjunction. You put in your own sentences here in between the quotes, and run this and see what this does. Especially if you haven't thought about grammar like this since you were in school, it can be helpful to refresh your memory about what all this stuff is. If we scroll down, we can also see the dependencies, or how the different words are related in the sentence here. They have these very nice trees. So we see, here's the proper noun. It thinks that this is the subject, which I don't think it is. I mean, Maximiliano is the subject here. This is the object, I would think. But so, I mean, it doesn't always get things correct. But you can sort of see where it's trying to put words into relationship with each other. This is also a very long and complicated sentence, which doesn't necessarily help matters. All right, so this is, if you're not entirely sure why you're getting the results that you're getting when you write code to try to extract things that you've annotated with Spacie, it can help to actually put some of the sentences that you're not sure of, into this code or into the visualization code below, to sort of get a sense of what Spacie sees and what it thinks it's doing. Here is some code for how to run the nouns only files, which is less interesting than the one after that. So I'll skip this for now. But I have a little description of what this does and what you might do with it next, once you have a noun only file for your novels. I sort of enjoyed putting this together, so I'll show you, if only for that. This is some code that I wrote with some troubleshooting help from Jennifer Isasi. Also fixing my typos with Jacinta, where I created a list of major characters in the novels here. There's our list. And then I sort of create a CSV where we'll write out all the character verbs, put in the path to the folder with all the source text. This is the same as before. And then this will create a new CSV that will show the character, and then it will show the verb that is the action that the character is doing, or at least that Spacie thinks the character is doing. This will take a moment to do, again, because it has to do its full annotation, dependency parsing. It even does named entity recognition as part of its default workflow for all of the docs. So this it won't take any longer than lemmatizing the files, but it will take a moment to get through all of it. Are there any other questions while we watch Spacie do its thing? Also, apologies in advance. I hear that my kids are now waking up, and hopefully they will go downstairs, but we may have small interrupters. So yeah, with more text, this can take quite a while. It can take on the scale of, I have another project looking at Star Wars novels in English, and there is about 400 of those, and it takes a couple hours to do this. So a good thing to run in the background. Actually, one thing to know about running it in Collab, Collab will actually time out after a few hours. That's one of the limitations on the free version. So you may need to do it in smaller chunks if you want to sort of do it and walk away. You may need to do a few, and then if it times out, you can do a few more. I mean, it should be able to run on the order of like a couple hours, but it does sometimes time out, and sometimes it happens kind of randomly, or it feels like it does. So don't be surprised if that happens. You don't lose your work. Anything that's been saved is still saved, but you may have to restart it if it times out. I guess I can walk through this code here. So you know, we have our text folder. We have our character verb file, which is the name of the output file that we created here. It takes that output file and then adds the header row here where it's character and then verb. And then for every file in our text folder that we specified above, if it ends with text but is not a lemmatized one and is not the nouns only one, then it will sort of take it as an input. And you do want to lemmatize here, but we'll get to that in the next step. One of the problems with if you're trying to be clever and you know, think, well, I already have this lemmatized file, I'll do the character verbs on the lemmatized file, that actually is not going to work terribly well, because the lemmatized file gets rid of the inflection that makes it clear who's doing the action. So you will get some character verbs, but you'll be missing a lot if you work on the lemmatized file, because the lemmatized file loses a lot of information that that Spatie kind of refers to when it's trying to do dependency parsing and part of speech tagging and all of that. So Spatie likes unlemmatized files. Anything doing word counts likes lemmatized files. All right, well, this was not too bad. This is 3 minutes and 33 seconds. So now we should see, here we go, our Fortunata Jacinta verbs. Well, I forgot to put a new line here. And so the first verb sort of got glued onto here. So let me fix that before we do the next step. I'll fix that in the code and update the repo so that you have a better working one down the road. This is actually a really interesting example here with Juanito Llevaron. If we look at, I noticed that and thought that was a bit strange, and I went back to the text itself and then threw it into the earlier part of that notebook where you can see what Spacey's doing and see the dependency tree, and it was Juanito y someone. There were two people doing the action, so it gets tagged for Juanito, but the verb is plural. Because there were actually two people involved in the sentence. Okay, can I get out of here? Oh no, I'm gonna delete this, and then I will save the. Oh, I'll save this as another CSV, and then upload that back because we'll need this for the next step. All right, we're gonna download this as a CSV. And then I'll re-upload it to the drive so we have a working version that will overwrite our bad one. Rename this. Okay, here we go. So it's almost as if, I'll delete this one. It's almost as if that little mistake never happened. Such potential for typos when you're doing code. So yeah, what I'll do is, I will fix this to add a new line, and I'll update the repo so next time you launch it, it doesn't have that problem. Okay, so this is nice, I guess. But if we're trying to look at all the things a character did, or if we want to look at it the other way, where if we take a particular verb and we want to say how many characters did this action, we're going to have a problem because of all of the variation in the word forms. So if we go back, we're going to lemmatize our character verbs. So this is the name of our output file, and we're going to read in our the file that we just created. And we're going to do it again. And so this goes a lot faster this time. As you can see, it's done already. It was completed in 7 seconds instead of like 3.5 minutes, because it's only lemmatizing the. Thanks, Rosanna. It's only looking at the verbs, the verb column, and it's writing out the lemmas to a new column here. So here we have our verbs lemmatized. Ta-da! Oh, yeah, no, that's right. So this is what we got. So now we can do. I have some other suggestions here for what you might do with this data. Thinking about different tools that you can use to explore it, different ways to analyze it. You can do things like split it apart so that you have a text file for each character, and then you can sort of compare like what the distinctive character verbs are for one character compared to another. And there are many more things once you have this data in hand that you can explore. So yeah, does anyone else have questions, or if you want to play around with it, I'm happy to stay for another half hour if anyone just wants to try to debug stuff. But yeah, this is more or less what I've got, which is to say this is a beginning for how you can explore computational methods with Spanish. It really is only a beginning, and the greatest challenge isn't even avoiding typos of the code, but trying to interpret the results that you get. But that is a challenge for another day. So, thank you.
Thank you very much, Quinn. And yes, we can stay some more minutes for questions, comments. ¿Alguien tiene alguna pregunta? Any question? So, okay, we have a question.
Oh, yeah. Social network analysis. So this is an interesting one. Yes. One of the biggest challenges with social network analysis in general is trying to decide what it means for two characters to have a link between them. So it all depends on how you want to define that. For characters to have a link, does that mean that they co-occur in the same chapter? Does that mean they have to co-occur in the same paragraph? Does one like literally have to be saying something to another one? There are lots of different ways to define those relationships, and the results you're going to get depend so much on how you define it and how you measure it. Once you've decided on a way to do that, you could do something like, for instance, if you want to say, if two characters occur in the same chapter, then they have a relationship. So you could split your text up into individual chapters and basically look to see which character names occur there, and then write out, you know, a link in between each of those pairs. If you want to do it more granularly and say, you know, paragraph level, you could basically, assuming your text is set up so that each paragraph is like a single line and there's a new line, you know, in a space for the next paragraph, you could cycle through that and look for the character names. I mean, you probably don't need spacey to, if you're just trying to match like occurrences of character names, but you could use it if you wanted like something very complicated, okay, relatively speaking, as I've seen people do this. And if you wanted to say, like, you know, Fortunata dijo a Jacinta, for instance, if you want to look at like character A said something to another person, there you have a syntactic relationship. You have one of the characters is the subject of the sentence, and the other is like an oblique object. And maybe you want to specify what the verbs are. Like if character 1 kills character 2, does that count? Yeah, I mean, probably. But I mean, one of the big challenges with the DH is always trying to decide what exactly you want to measure and what you want to count. But if you wanted to set something up so you basically count a relationship anytime there's character 1, or there's a character as a subject and a character that's a direct or indirect object, then you can set up those rules using spacey. But usually if it's just like two character names co-occur within a certain range of each other, you can just search for them in the text with Python, and you don't need to involve the whole spacey extravaganza. Oh, stemming. So you don't, stemming is often what you fall back to if you don't have lemmatizing available. It works the same way, basically, to reduce the amount of variation in the text. But it's easier to do computationally, which is why it's available for languages like Turkish that don't have necessarily a good lemmatizer. Turkish is also more complicated for other reasons grammatically. But usually if you have a lemmatizer available, you use that instead of a stemmer, because a stemmer will just chop off endings and prefixes, and what's left may be the word root and it may not be, and it's generally harder to read. So lemmatizing is like stemming, but better if you have it. Oh yeah, and as Nuria points out, once you have the data of you know, characters that you've pulled out of the text, you can use Palladio, one of the fine products that one of my colleagues, Simon Wiles, supports at Stanford, to visualize those relationships. Any other questions?
So, Quinn, I think we get a very good time with you, and I think that if there is no more questions, we can leave the talk as it is.
All right. Well, thank you all for coming. I am easy to find on Twitter, and always happy to answer questions and things like that. So yeah, feel free to get in touch.
Sí, muchas gracias a todos, y bueno, y será un placer la siguiente sesión de Intelle, en la 4ª sesión, y bueno, pues gracias por asistir hoy otra vez. Hasta luego.